All right, guys, finishing the note sheets from yesterday. All right, guys, need your note sheet from yesterday. Note sheet from yesterday. So what we talked about yesterday was our transformations. All right, guys, focus in, focus in. So we're talking about our transformations. So yesterday we talked about vertical translations, moving the graph up or down, moving it up or down. And that was our k. When we had a value in the place of k, we were moving the function up or down by that amount. We also had horizontal translations, which moves the graph to the left or to the right for h. And we also figured out that with h, the way it looks, especially in the function, is going to be the opposite of what we're actually looking at. So if we had x plus 3 inside the absolute values, it's actually moving 3 units to the left. X minus 3 is actually 3 units to the right, opposite of what we think. Then we talked about reflections across the x-axis. If A is negative, if the value of A is negative, it's going to be a reflection across the x-axis. Not so much the number itself, but if that number is negative, it's a reflection across the x-axis. And where we finished off was with vertical stretch and vertical shrink. We hadn't done any problems with it, but we said a function has a vertical stretch when A is greater than 1. And it is a vertical shrink if A is between 0 and 1. If the value of A, the number where A is at between 0 and 1, it's a vertical shrink. If the value of A is greater than 1, it's a vertical stretch. I also mentioned yesterday, we kind of talked about it as the absolute value of A is greater than 1, or 0 is less than the absolute value of A is less than 1, because we're looking at the number, not the sign. The sign connected with A tells us if it's a reflection or not. The value of A tells us if it's a stretch or shrink. The only time we would not have a stretch or shrink is if the value of A is 1. It's not stretching, it's not shrinking. Because when we stretch the function, we say it has a vertical stretch, we're increasing the values of y faster, so it's increasing faster along the y-axis. If we shrink it, it's increasing slower. And the way this looks graphically, especially with absolute values and quadratics, is that the sides of the function get closer together when we stretch it. When we shrink it, it gets farther apart. So if we look at this first one here, g of x equals 2 times the absolute value of x. We first want to say what parent function, what group it is with. Well, absolute value, absolute. Because the absolute value functions kind of give it away, because we have to say absolute just to read the function itself. And if we look at it compared to the general form, A, absolute value of x minus h, plus k. Do we have a value for k? Do we have any movement up or down compared to the parent function? No. How about left or right? So h, if we had h, kind of a number being subtracted from x inside, yes, we would have left or right, but unfortunately we don't. Is the value of a negative? No. So there is no reflection across the x-axis. All we have is that the value of a is 2, yes? Is that greater than 1 or between 0 and 1? Greater than 1. So what we'll say is, yes, it is a vertical stretch of 2. Vertical stretch or 2. When we talk about vertical stretch or shrink and when we'll talk about horizontal stretch or shrink, we have to specify by how much it's being stretched or shrunk. We need that scale factor. Just like with moving it left, right, up, or down, we say how far it's moved. Same thing with stretch or shrink. So the top one is our normal absolute value. The one below it is the one we just did. And if I graph this here, we can see the one in red is our starting, or our blue is our normal absolute value. The red is the vertical stretch. We can see it is increasing faster along the y-axis. So it was stretched. It was increased by a factor of 2. I also put in here this one here. So now it's not instead of 2, it's 1/2. 1/2 is indeed between 0 and 1. So this here would be a vertical shrink of 1/2. If we look at its graph, we can see that it is indeed wider than the one in blue. It's increasing slower. And the smaller this fraction is, the wider, let's say that graph becomes. Because it's increasing now 1/19th the rate it would normally go. Instead of having normally a value of 1, the y value of 1 is now a value of 1/19th. So it's increasing a lot slower. The opposite is also true. If we make this value bigger, so now it's a vertical stretch of 9, that function is going to get very narrow because it's increasing 9 times as fast. So when the y value used to be 1, it's now 9. If the y value was 2, it's now 18. It is increasing faster. Questions on the first problem? So problem number B, which family is this here? 1/2 x squared. Yep. Quadratic. Again, do we have a value for h or k? No, but we do have a value for a. A is what? 1/2, yes? So that means we have either a vertical stretch or a vertical shrink. Is a's value greater than 1 or between 0 and 1? Between 0 and 1, so it would be a vertical shrink of 1/2. Yep. That's it. Questions on B? We already looked at number 5. What is the parent function that g of x equals 3x belongs to? Linear. Well, again, do we have value for k, moving it up or down? Do we have value for h, moving it left or right? Do we have value for a? Is it negative? No, so there's no reflection. But the 3 is telling me that there's either a vertical stretch or vertical shrink. Vertical stretch because 3 is indeed bigger than 1. So it's a vertical stretch of 3. Questions on this here? We ready for the next one? H of x equals 3/2 x squared. Family would be quadratic. Again, just like the last 3, there's no value for h, there's no value for k, but there is a value for a, yes? It's not negative, so there is no reflection. And because it's a fraction, it is a vertical shrink. Yes? It's a vertical stretch. Because what is 3/2? Is 3/2 between 0 and 1 or bigger than 1? Bigger than 1, so it has to be a vertical stretch. Just because it's a fraction does not mean it's going to be a shrink. Stretch of 3/2. Yep, it's a vertical stretch. Because it is sometimes tempting to see a fraction and automatically assume it's going to be between 0 and 1. Not necessarily. Last one. Right here, number 7. 0.2 absolute value of x. Absolute value. Now we need to determine if it's stretch or shrink. It'd be a vertical shrink because 0.0 or 0.2 is indeed between 0 and 1. So would it need to be a vertical shrink of 0.2? Questions on anything we've done so far? We feel good with this so far. All right. Look at the last thing we're going to cover. Identify the family at which it belongs to. Then compare the graph of f to the graph of its parent function. All it's saying here is what family does this function belong to? Describe the transformation. So the parent function would be absolute value. Part of the absolute value function. So a absolute value of x minus h plus k. So when we describe the transformation, first thing we're going to look at is, we can look at h. Is there a movement left or right? No, there is no value inside the absolute value, so there is no movement left or right. Is there a value for k up and down? Yes. How far are we moving it up or down? Up 1. So we transform, we move this function up 1, yes? All right, so we're done with this one, yes? Is there a value for a? Okay, because up to this point, we've only had one transformation. We did one, that was it. Here we do have a value for a, and it's 2. It would be a vertical stretch of 2. Because we can have as many transformations as given, because we could have a reflection across the x-axis. We can have a vertical stretch or shrink. We can move it up or down or left and right. We can have all of them. Don't have to be, but it is possible to have all of them. Because if there's a value for a, h, and k, that means there's a transformation being applied to it. Here, vertical stretch of 2, because the 2 is positive, there is no reflection. There is no left or right movement because we have no value for h. And then the value for k, positive 1, moves it up 1. So up 1, vertical stretch of 2. That's it. Questions on this here? One-fourth times x minus 3 squared. What's its family? Quadratic. Do we have a value of k, moving it up or down? Do we have a value for h, moving it left or right? So it is 3, yes? Would it be left or right? Right. It would indeed be right 3, because again, left and right is the opposite of what we think. X minus 3 makes us want to think it's going to the left, but it's actually going to the right. We have a value for a? Yes. Is it negative? No, so there is no reflection across the x-axis. But it is 1/3. 1/4, thank you. So it's going to be a vertical shrink of 1/4. That's it. And that's the nice thing with these transformations. We look at a, h, and k. Is there a value in one of those spots? If there is, we connect it to its transformation. If there's not, there is no transformation there. I mean, we could say that there is a transformation of 0 up. It means nothing, because it's not telling us anything. It's not moving. We're not going to say that. We're not going to list it. Let's do one more. G of x equals negative absolute value of x plus 5 minus 3. So this is going to be absolute value. Now the only thing it won't have is what? Because it's going to have, it's missing one transformation. Yeah, there's no vertical stretch or shrink. But it does have everything else. So how far are we moving up or down? Down 3. Left, right. Left, how far? 5, because again, it looks plus 5. It looks like it should move 5 units to the right. Nope, we're moving 5 units to the left. A is negative, so we would indeed have a reflection across the x-axis. And that's it. Really, the only transformations we're missing out of all of them that we could have is a vertical stretch or shrink, horizontal stretch or shrink, and a reflection across the y. So there's 3 more that we could have. But this pretty much covers it all. Questions on this here? Homework, problems 3 through 5. 3 through 5. Identify the parent on 3 through 5 and describe the transformation. That's what it's asking. 9 through 15 odd. So problems 9 through 15 odd. Odd numbered problems from 9 through 15. So 9, 11, 13, 15. Describe the transformation and name the parent function. So name what group it belongs to, describe the transformation. You do not have to graph it. 3 through 5 all. 9 through 15 odd. 19 through 25 odd. So 19 through 25, the odd problems. Name the parent function. Describe the transformation. Do not graph. And then 27, 28, 31, describe the parent function. Tell which one it is. Describe the transformation. Do not graph. Throughout the entire semester, unless I specifically tell you to graph it, do not graph. Okay? You have the rest of the class time to work on it.